Assalamu alaikum. Today we're going to start with the chapter sets. So first we're going to learn how do we define sets. If I have this set as written as A is equals to X is such that X is a natural number. What do I mean by that? Now it means that X is a natural number. That's the simple meaning. So A, all the values in set A are natural numbers. What is a natural number? A natural number is any number greater than 0. So X becomes a number that is greater than 0. In other words, I can say that A is equals to 1, 2, 3, and so on all the way till infinity. Okay, that says B is equals to X comma Y is such that Y is equals to mx plus c. Now, what does that mean? That means that X and Y are coordinates because they're written in the form we write coordinates. They're written as X comma Y, which makes them coordinates, but they're coordinates such that they will fulfill the equation Y is equals to mx plus c. So if I take the value of Y as 1, then the value of X should fulfill the equation Y is equals to mx plus c, and 1 minus c is going to equal mx, and x will equal 1 minus c divided by m. Any value of x will have to fulfill this equation. That is what I mean when I say that the coordinates of x and y are such that they're going to fulfill the equation y is equals to mx plus c. Moving on to set C. Set C says that x is such that A is less than or equal to X, which is less than or equals to B. So A and B are going to be any two values that will either be given in the question or you will have to calculate them. And these two values, A is going to be smaller than X and B is going to be larger than X. Let's move on to set D. If I say that set D contains the elements A, B, and C, that means, and so on. That means that set D contains A, B, C, D, E, and so on till the last alphabet, Z. So all the elements of D are the alphabets. So we can say that D is a set that contains the English alphabet. Let's move on to the common terms that we use while we study sets. So here I have an image from the CIE syllabus, and let's see what that tells us. Firstly, they say that what is n bracket A? N bracket A means the number of elements in set A. So if I say n A is 1, it means that the set A just contains one element. That could be any element. Then the next thing, if I say that, if I use this sign looks like this. It's a kind of a fork, and that means is an element of. So if I say X, E, this element of sign A, I mean X is an element of set A. Then moving on, if you have that cross on this fork kind of symbol, it means it's not an element. So if I say that Q is not an element of set B, it means that Q is not included in the set B. Then what do we have is this small flick apostrophe kind of symbol that you can put in front of any set. So if I say B complement, it means that anything that is not in B. If I say that I have a total numbers of 1, 2, 3, 4, and 5, and B contains, I have 1, 2, 3, 4, and 5, and set B contains all even numbers. So that gives me 2 and 4 in set B. And so I'm left with 1, 3, and 5 outside set B. So if I'm asked for B complement, which means anything that is not in set B, it means 1, 3, and 5. Now, the next thing is this stylish E symbol, which is the symbol for a universal set, which means I will donate a universal set using this image, which means it includes all the elements that are in the universal set. If I say that the universal set, this E includes all natural numbers, it means that it includes all numbers greater than 0. Now, when I say A is a subset of B, and I use this symbol to denote that, I mean that all the values in A are equal to all the values in B. So if A includes 1, 2, and 3, B also includes 1, 2, and 3. Both the sets include all 3 values. But if I say that it's a proper subset, A is a proper subset of B without using that small line in the symbol, I mean that B at least has another value that is not part of A, which means that if A has 1, 2, and 3, B is going to have another value along with that. 1, 2, 3, at least another value, 4. It can also have 5, any other additional value. So if I'm denoting set A, set B like this, and I'm saying that A is a subset of it, so there will be some value in this yellow region. Moving on, then we have A is not a subset of B. So how will I denote that? A is not a subset of B, which means that all the values of A are not all the values of B, and A is not a proper subset of B, which means that that extra value, it's not included. Then if I'm using the term A union B, which is a very popular term, it means that all the terms in set A and set B combined. If set A has the numbers 1 and 2 and set B has the numbers 7 and 8, then A union B becomes 1 and 2 and 7 and 8. But what if I say A intersection of B? Then A intersection of B is going to be the two values that are intersecting between the two sets. So for example, A is P and Q, and B is Q and R. Which value is intersecting? Which value is common in both the sets? Q. So A intersection B becomes Q. Now let's try out some past papers to see if we've understood the topic. Now we're going to start with past papers. So the question says that sets A, B, and C are shown in the diagram. Now let's see what part A says. So part A, part 1 says find the number of elements in A union B. That means we need to find everything in A union B. So let's see first what's the universal set. What's E? E is such that 1 is less than or equal to x, which is less than or equal to 18. That means that if I put 1 in place of x, that's going to fulfill the expression. Yes, it does. 1 is less than or equal to 1, which is less than or equal to 18. If I put in 7, it also fulfills. If I put in 17, it also fulfills. If I put in 18, it also fulfills. So what does the values in the universal set become? Everything from 1 to 18 is part of the universal set. Now let's have a look at A. A says even numbers. So the even numbers are 2, 4, 6, 8, 10, 12, 14, 16. And what does B say? B says a multiple of 5. And what are the multiples of 5 over here? 5, 10, and 15 only. Now you need to find the number of elements in A union B. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total elements in A union B. Now let's move on to part 2. That says, given that A intersection B complement intersection C complement is 2, 6, 14, and 18. We need to list the elements of C. So let's have a look at the set at the top, the image that we've been given at the top of the question. And that shows you all these sets. So what is A intersection B complement? What is B complement? Anything outside this blue circle is B complement. B complement is anything but B. So B complement is everything outside set B and the intersection of A with B complement. What is intersection? Whatever is common between the two sets. So what is common between A and the complement of B? This is the complement of B, everything outside the blue circle. This is set A. So what is common? This whole part is common. And so this whole blue colored area becomes A intersection B complement. So what are going to be the values of that? Everything in set A that is not part of B. What was part of A and B? 10 only, because 10 is even and 10 is a multiple of 5. So what are we left with? We're left with 2, 6, 4, 8. We'll leave out 10 because that's part of set B. 12, 14, 16, 18. These are all elements of set A that are not elements of set B. So this is A intersection B complement. Now we need to find the whole of this. How does it intersect with C complement? How does it intersect with everything outside C complement? So what is everything outside C? Well, how is it intersecting? Well, I'll show you how. Let me erase all this. Now, how is this is the value. These are all the values in when it forms with C complement. So let's see, let's remove everything from here that is part of this whole question. So 2 are common, 6 are common, 14 are common, 18 are common. Whatever is left will be inside C, because all this in the red was whatever was C complement. C complement means everything outside C. So what's left inside C? 4, 8, 12, and 16. Let's move downwards and let's write that down. 4, 8, 12, and 16. Now they're asking us to describe set C in words. Describe this set in words. How are we going to do that? It's very obvious. What's common between 4, 8, 12, and 16? The number 4. So the C is equals to X is such that X is a multiple of 4. That's very clear. Let's move on to B part that says, a school offers piano lessons and flute lessons to a group of 50 children. There are 50 children. The number of children is 50. Of these, 28 attend piano lessons. Let's denote that by 28P. 17 attend flute lessons, and 12 attend neither piano lessons or flute lessons. So we need to find the number of children who attend only piano lessons, which means that this value that we have, that 28 students attend piano lessons, it also includes students who play both the flute and the piano. So let's draw a Venn diagram for that. This is our universal set. Now, how many students are outside who do not attend? 12 of these 50. Okay, there are 12 students outside. And let's make one for piano. This is set P. This is set F. And that is this section in between that they're intersecting. So what happens? We need to find out how many intersect in the two of them. Now 50 minus 12, let's see. 50 minus 12 is 38. So there are 38 students in set P and F combined. But according to these statistics, we have 28 and 17. So 28 plus 17 gives us 45. So we know that 38 students are attending either piano lessons or flute lessons, but from this statistic, we can see there are 45. So it means that some students are attending both piano and flute lessons. Let's subtract 45 minus 38 to see how many of them are doing so. So 45 minus 38 gives you 7. And that means that 7 students are attending both piano and flute lessons. So when we have that, let's go back to the question that says that 28 attend piano lessons. So 28 minus 7 gives us 21, and 21 are left here. And 17 attend flute lessons. 17 minus 7 gives us 10. And now if we add 27 plus 7 plus 10 plus 12, we get the value as 50. So we have this correct Venn diagram. What do we want to find? The number of children who attend only piano lessons. That's 21. Now the question says, using set notation, describe the shaded region in the Venn diagram. So firstly, we can see that the whole set A is colored. So the whole set A is there. We need to describe this in words. Then along with that, there is some part of B and some part of C. What part of B? The part that is intersecting with B. So A intersection. So we have the whole of set A, plus we have the part that A is intersecting with B, and we have the part where B is intersecting with C. So let's see that when I'm saying, I'll say that I need to find the union of A, the whole set A, where it is where B and C are intersecting. So does this fulfill that? Let me write it down again over here. The union of A with B intersection C. Okay, so let's see, B intersection C. B intersection C is all this part, B and C are intersecting, and we're finding the union, everything that is in A and the intersection of C. What is all in A? This. So we describe the whole region. Let's move on to the next question. Okay, in the Venn diagram, shade the region represented by P complement where it intersects with Q union R. We need to find what is Q union R. Q union R is this whole region. What is P complement? Everything outside P. So let's first see what is everything outside P. Everything outside P is outside this blue circle. Everything outside that blue circle. Now, where is everything in Q and R intersecting with everything outside P? It's intersecting everything outside P. And where is it? Everything outside P becomes this. But where is it intersecting with Q and R? It's intersecting with Q and R over here only. So only this red region is the correct region for this place. So let me shade it properly. This is the whole region we are supposed to shade. You can see this is fulfilling this. This is the intersection. This is where everything outside P is intersecting or is common with everything inside Q and R. P is such, the universal set is such that X is an integer from 10 till 21, so the whole set E becomes any value from 10 to 21, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Then X is an even number. Set E says that X is an even number. So what are the even numbers there that become part of set E? 10, 12, 14, 16, 18, and 20 are part of set E. Then, what about set M? M is a multiple of 5. So what are the multiples of 5? 10, 15, and 20. Then what does P say? P says X is a prime number. So where is X a prime number? Where are the prime numbers? Firstly, we have 11, then we have 13, then we have 17, then we have 19, and that's it. They're asking us, the question asks us, the Venn diagram shows the universal set E and the subsets E and M. And you can see the whole set E, the intersection of E and M is including 20, which we can see is true because set E also includes 20 and set M also includes 20. Here as well, set E and M both are including 20, and set E only includes 12, set E only includes 12, correct. Okay, so they're asking us to draw the subset P. Where do we draw the subset P? P is 11, 13, 17, and 19. Now, where is 11, 13, 17, and 19 coming? It's coming somewhere outside, because 11, 13, 17, 19 are not part of M or P, so, or M or E, so it's going to be outside. Your set is going to be, set P is going to be somewhere here. And then write the remaining 10 elements of E in the appropriate subsets of your Venn diagrams. So the universal set, we're going to fill the whole diagram with the remaining elements of E. So we're going to put everything in its place. We're going to put all these values of P inside P. We're going to put all the values of M inside M. But since 10 is also even, we're going to put it here. We're going to put all the values of E inside E. And that's how we do this. Now, it says the Venn diagram shows the sets E, P, Q, and R. And they've given you what the universal set contains. It contains numbers from 1 to 10. And the question says, find the value of N, Q, union R, the number of elements in Q and R. So let's just simply count that. 2, 5, 9, 6, 3, 7, 8, 4. How many do they become in total? 1, 2, 3, 4, 5, 6, 7, 8. Yes, these are 8. 1, 2, 3, 4, 5, 6, 7, 8. Then list the elements of the set P complement intersection Q union R. Where does Q union R, everything in Q and R, intersect with everything outside P? So what is P? P contains 1, 4, 2, and 3. We cannot use 1, 4, 2, and 3. Apart from 1, 4, 2, and 3, what is there in sets Q and R? We have 5, 6, 9, 7, 8. So that becomes our answer. 5, 6, 9, 7, 8.